What was the first step?
So collection.
First step is collection. Now, regarding collection, it depends on the type of tissue which we are going to process. Right? I mean, tissues might be present superficially or might even be present very deep to the skin. Depending upon the location, there are different methods of collection. But when I'm speaking of processing of the tissue, then the first step should not be collection, because collection is not processing. Processing begins after we collect. If you are not collecting anything, then what are you going to process? Are you understanding? So when you are asked the next time that what is the first step of processing of tissue, make sure you name that step as fixation and not collection. Clear, Urmili?
Yes, sir.
Fixation should be considered as the first step of processing the tissue, because the step begins only after collection is over. Right? Now for fixation, let me first give you the definition of fixation. Write down. Fixation refers to treatment of the tissue. Is my writing clearly visible at everybody's end, or do I need to make the ink more thick?
Sir, make it a little more thick, sir.
Thick, okay. It is much more prominent, right? Now?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
So for the sake of prominence, let me overwrite whatever I have written. Refers to treatment of the tissue with chemical agents that, now here comes the important point, that not only retard the alterations of tissue, tissue, after alteration of tissues subsequent to death. So normally what would happen? If I am collecting the tissue out of the body, that means there will be death. Right? So after removal, there will be death. The removal from the body, there will be death. So that is one purpose. What is the purpose? Retard the alteration of tissue subsequent to its collection. But another purpose is also to maintain normal architecture of the tissue. That means the structure, as I was telling every time, that the purpose of fixation is to retain the lifelike structure. Okay, these two are the purpose of fixations that I have written on the board. And for this, there are multiple fixative agents available. But for light microscopy, some specific fixatives are formalin, and another worthy of mentioning is Bowen's fluid. Now, say if you are performing a different microscopy, you can process a tissue, say for example, you can observe a tissue under an electron microscope as well. For that electron microscope, there is a different fixative to be used. Okay, so when I will move on to the details of individual types of microscopy, then I will discuss all the commonly available fixatives. But as of now, I have mentioned here the two most common fixatives to be used for the microscopy. Now, what actually do this fixative do? We know
Hello, sir.
that tissues are made up of proteins. Yes, hello, Anjali.
Sir,
Devanjali, right?
formalin.
হ্যাঁ, formalin.
ফরম্যালিনের পরেরটা কি লিখেছেন বুঝতে পারছি না।
Bovin, BOUIN. আমি তো সব ক্যাপিটালে
Okay, sir.
লিখেছি এই জন্য। Bowen's fluid or Bowen fluid.
Okay, sir.
Okay. এখন, what do we know is that tissues are what? Tissues essentially are made up of proteins. We are having that knowledge from the lessons of biochemistry. Essentially made of what? Made of proteins. I mean, if we have to speak of the structural aspect of a tissue, then the structure of any part of the biological existence is made up of what? It's made up of proteins. Protein ছাড়া তো কোনো গঠন হয় না. Right from the hair till the bones presence inside, we are having proteins everywhere. Right? Now,
Yes, sir.
the prevention of the loss of structure is possible only when adjacent proteins, there are proteins everywhere. If these proteins can be cross-linked. So what is the exact term that I've used? Cross-linkage. I mean, formalin and Bowen's fluid, both these two fixatives basically cross-links individual proteins. And as the proteins are all cross-linked with each other, that means there will be a retention of the structure. How? Because the proteins, as they are cross-linked, they cannot change their position. Biological system যেখানে যে প্রোটিনটা in the living condition was there, সেখানে সেই প্রোটিনটাই থেকে যাবে once the adjacent proteins cross links with each other. But if the cross linkage phenomena is not present, মানে biochemistry, what have we learned? These proteins are usually hydrated. মানে কি water থাকে, right? Now the moment we bring this living tissue out of the living body, from that moment onwards, this water starts evaporating quite naturally. So once the evaporation phenomena sets in, the proteins will tend to lose their biological positions. And as the proteins tend to lose their biological positions, the proteins will now get scattered away. ছড়িয়ে যাবে proteins গুলো. So structural integrity টাকে maintain করার জন্য, in order to retain the structural integrity, what is needed is to avoid this scattering or dispersion of the protein. And that avoidance is possible by cross-linking these individual proteins. So as the proteins are cross-linked, that means new bonds are formed between the protein molecules, and those new bonds keep the proteins in their own biological positions inside the tissue and the cell. Thus, structural retention becomes possible. Did everybody understand?
Yes, sir.
Structural retention means lifelike conditions in respect of position of individual proteins in relation to each other. Mujhe galo? Any doubts? So if this is over,
No, sir.
fixation, we have come to know that how is fixation possible? That is by the cross linkage of the positions of the proteins present in the living state. So once those proteins are cross linked, we can have the retention of the biological structure. Now, naturally, there will be some removal of this hydrating water in between the protein molecules. That is true. But we need to remove that water that doesn't naturally evaporate. I think I explained yesterday that if water be kept or be made to remain present everywhere inside the cell or the tissue, that means when I will try to stain for the purpose of differentiation, then everywhere inside the tissue or the cell will get the stain dissolved in it. Thus, differentiation would not become possible. So that's why we do need to remove H2O. In one word, we now need to move to the next step of the processing, and that step is dehydration. Okay. So for dehydration, what do? We use graded series of alcohol to begin with. We'll be using 50% alcohol, and will progress further until we reach the 100% alcohol. Now, did you understand the concept? So suppose I have collected a tissue. Suppose if this be my tissue. Okay, I'm writing T on this word, tissue. So I'll be putting this tissue in a solution that is having 50% alcohol or ethanol, most commonly. So if this tissue is put into this solution, then part of the water of this tissue will escape into this alcoholic material, but not the whole. So in order to have the remaining part removed from this tissue, this same tissue if we draw this tissue dipped into the 50% alcohol, this same tissue would have to be transferred to another alcoholic material, which is having, say, depending on the type of tissue, 55% alcohol. That means we have now increased the grade of the concentration of the alcohol. So if this be the tissue inside the alcohol, after the 55% alcohol, we will move now to the next grade, which will be, say, 60 or 65% alcohol. So the same tissue is being moved along a series which is having alcoholic concentration graded. Clear? So this step is to continue. This step is to continue more. Finally, there will be a beaker which is having 100% alcohol. This same tissue, after multiple such containers, would finally be moved into the container which is having this 100% alcohol. So once the tissue is put into this 100% alcohol, the majority of the water or maximum amount volume of the water will now be in this 100% alcohol. That means we do not have any other options to remove further water. Understood? So the dehydrating material is what? The dehydrating material is the graded series of alcohol. This is how we move the tissue across the different grades, concentrations of alcohol, so that the water content of the tissue is removed. Now, in each step, what can happen is, suppose this is the first step. If we are keeping this tissue for prolonged duration of time, so the water will be removed, that is true, but there is a limitation to the removal. Limitation to the removal means water will be removed until the concentration both inside and the outside of the tissue becomes equal. So let me zoom this or give you a larger diagram. If this be the solution inside which I have placed this tissue T, so once placed, the water H2O will be removed out, but at the same time, the alcohol, what is alcohol? Having OH group. Try to recall your lessons in biochemistry. So that OH group alcohol will gradually enter. That means there will be a substitution or a replacement of the water present biologically by the alcohol to which or with which we are treating the tissue. So the alcohol would enter and water would exit out of the tissue. But that exit of water is having a limit. What is that limit? That limit is the concentration. So once the concentration of the alcohol, both inside and outside the tissue, becomes equal, thereafter there will be no further exit of water out of the tissue, right? Did you understand now? So the exit of water will stop at that particular point when the concentration between the outside and the inside of the tissue would become equal, correct? So that is why, in order to make more water exiting out of the tissue, we now need to move to the next grade. That means an alcohol of a higher concentration. Having the alcohol of a higher concentration will cause additional amounts of water to exit the tissue, as well as additional substitution. What is the ultimate consequence of this substitution? The ultimate consequence is that as we move through this graded series till the last container, we can have excess of dehydrate, right? At the last position or the condition, we'll be having an excess of the dehydrated material, which now needs to be cleared off. Understood? Because nothing in excess is required, neither is required anything in shortage. So things now needs to be cleared off so that only the amount that is required for substitution remain present inside the tissue. And exactly for that reason, we have the third step as clearing. So how do we clear it? We treat the dehydrated tissue, not the tissue that we have collected, but the tissue which we have fixed and thereafter dehydrated. So treat the dehydrated tissue with the clearing agent, and the most common clearing agent is known as xylene. Xylene is miscible both with this alcohol as well as with paraffin. Paraffin is the material that we are going to use in the next step. Okay, but xylene here acts as an intermediary. That means by being miscible with the alcohol, the excess alcohol would thus be removed. Xylene cannot form any bond with the natural biomolecules. Since xylene cannot form any bond with the natural biomolecules, there is thus no question of xylene being retained inside the tissue. Understood why xylene cannot stay inside the tissue? But alcohol can stay inside the tissue, because already in the biological system we do have multiple varieties of alcohols. Try to recall, carbohydrates are actually polyhydroxy alcohols having the OH group. Remember? Okay, so proteins are also having similarly alcoholic groups. So alcohol can be retained, whereas xylene cannot be retained. Now the excess amount of alcohol that has entered into the tissues, that will get dissolved once that dehydrated material is dissolved in a solution, in the liquid of xylene. So once it is dissolved in the liquid of xylene, the excess alcohol, that means the alcohol which is not binding to the biomolecules, or which even if binding is very weakly binding, that alcohol would get dissolved into the xylene. So the excess amount of alcohol being dissolved into the xylene is now removed from the tissue which we are processing for microscopy. Understood? And at the same time, since xylene can mixed with paraffin, so the xylene in one way do also help or contribute to the next step. And the next step is, that means the fourth step is embedding. Regarding
Hello,
embedding,
sir.
hello.
Sir, I have a question.
Yes, ask Anjan.
Sir, you said that we have to put the tissue in all the containers of higher percentage of alcohol. In results, we are getting the excess dehydration. Sir, why we are doing this?
So as to remove the water. The
So
purpose
we
is
can
to
stop this after, I mean, 60% or 65%. Why we are putting to 100%?
okay. It depends on the amount of water present in the tissue. Suppose we are processing a bone tissue,
Okay.
or we are processing a tissue from our teeth. In that case, we do not move, we are not in the requirement of moving to the 100%. But say, for example, we are working with a liver tissue or with a brain tissue, which is having higher quantities of water. So once the water quantity be high, in that case, the necessity of removal extra amount of water is also high.
Oh, yes.
So when we are working with those types of tissue, which is having the requirement of removing huge amount of water, in those cases only we are moving on to the higher percentages. It's not always necessary that we have to use a higher percentage for all the types of tissue. That is not the universal one. Here.
Yes.
Okay. But no matter which percentage we use, there is a chance of an over dehydration. Over dehydration means over substitution with the alcohol, with the dehydrating material. And exactly for that reason, we now need to remove that dehydrating material in the third step, that is the step of clearing. Clear?
Yes, sir.
Okay. Now, the agent that we use for clearing should at same time be very easily miscible with alcohol, because if anything be not miscible with alcohol, you cannot remove that excess dehydrating material, that is the alcohol, out of the tissue. So that's why miscibility with xylene or the clearing agent is a necessity. And at the same time, the xylene is used because xylene is equally miscible with paraffin. Now, being equally miscible with paraffin makes the embedding process easier. Why? Let me explain here. Suppose if this be the tissue, I am writing the word T again to represent the word tissue. And I have put this tissue in a mass of what? Xylene. So consider that this particular color represents xylene. Right. Now the tissue is already a dehydrated one. Being a dehydrated one, chances are high that there will be an excess of the dehydrating material. And that excess of dehydrating material is now being removed into the xylene. What is that dehydrating material? That is OH group, or the alcohol group containing material. Right? Understood? Now, as the dehydrating
Yes, sir.
materials are being removed, what is happening is, once you take this tissue out of the xylene, this same tissue T is going to retain a very fine film of the xylene material. Very fine film. Say I'm drawing that fine film of the xylene material around the surface. So this is because of the xylene, right? And this is the tissue present within the xylene. Now, if the xylene at the same time be very miscible with the embedding material, so let me pick up this green color so as to indicate the embedding material. That means the material would now easily form bond with this fine film of xylene. Are you understanding? So the embedding material will stay along with the tissue. That is the necessity, that the embedding material stays along with the tissue. I do not want the embedding material to be removed. I want the embedding material to stay along with the tissues, but it should not penetrate the tissue. Because if it penetrates the tissue, then the internal structure of the tissue would again get disturbed. Structural loss can again occur if it is penetrating. So the embedding material should remain only on the outside of the tissue, and it should never penetrate into the inside of the tissue. And that is ensured by this thin film of xylene, which is easily miscible to the embedding material. That embedding material is known as paraffin. Got it? Now, if paraffin and xylene mixes up very easily, that means the layer of xylene, I mean the fine layer of xylene, would not allow the paraffin to leave this layer. So if the xylene doesn't allow the paraffin to leave its layer, that means there is no possibility of paraffin entering into the interior of the cell. So paraffin would always be there on the outside of the cell. Did you understand how xylene prevents the entry of paraffin into the interior of the cell? Did you understand this concept? समझे ना? Xylene का एक फाइन फ्लेम टिश्यू के बाहर रह जाता है। Xylene একটা পাতলা লেয়ার টিস্যুর বাইরে থেকে যাচ্ছে। তার রেজাল্টটা কি হচ্ছে? Xylene যেহেতু প্যারাফিনের সাথে খুব ইজিলি মিক্স করে যায়, তার ফলে প্যারাফিন যখন xyleneর কন্ট্যাক্টে এলো, ওই কন্ট্যাক্টের পরের থেকে প্যারাফিন আর বেরোতে পারবে না। আমাদের পারপাসটা কি? পারপাসটা হচ্ছে প্যারাফিনটা যেন থেকে যায়, বাট টিস্যুর বাইরে থেকে যায়। It should not enter inside the tissues. Now, কোনো কিছু যদি টিস্যুর ভেতরে ঢুকতে হয়, তার মানে এই ফাইন ফিল্মটাকে ক্রস করতে হবে। কিন্তু ফাইন ফিল্মটা যদি ইজিলি মিসিবল হয় প্যারাফিনের সাথে, তাহলে ক্রস কি করে করবে? xyleneটা তো যেহেতু ইজিলি মিসিবল, এটা আটকে রেখে দেবে প্যারাফিনটাকে এই ফাইন লেয়ারটার মধ্যেই। ক্লিয়ার?
Yes,
So,
sir.
Yes, sir.
Xylene
Yes,
in this way also contributes to this fourth step of the processing, and this fourth step of the processing is known as embedding, right? I will discuss and will make you write few more details about embedding, but in the refresh session. Join me in the refresh session, which is to begin just
Okay,
about
sir.
5 minutes after the current session gets over.
Okay,
Okay,
sir.
so as to process the recording.
Okay, sir.